Hello, good day. Timothy is here. So I'll be taking you through the statistical machine learning assignment that I just concluded. So one of the most important part of this assignment is that it actually exposes me to a lot of things, a lot of processes that machine learning actually takes. Take for example, we went through the 9 wheels of statistical machine learning on the air quality classification problem. I've been curious for quite a while now that okay, how can the air quality around us actually influences how people are healthy, how healthy they are due to the air quality that is around us, which actually led me to this particular dataset called the air quality dataset. So this air quality dataset comprises of 15 features. In these features, we also have the target variable among them. So this target variable comprises of three different things that I actually categorize it to be: good air quality, moderate air quality, and poor air quality. So this is a classification problem. So how can I classify this particular data set into this using the data set that I have? So these are the problems that I have been so curious about, which now led me to go into the 9 wheels of statistical machine learning. The first part is the clear definition of the problem that I have. That is classifying the air quality based on different features of data set into good, moderate, and poor. Upon knowing the problem, I move on to the data collection. This is where I went to Kaggle to get the data set, to prepare it, and also understand all the variables, how the variables are actually related together, which actually led me to seeing that nitrogen dioxide and also carbon dioxide actually are somehow correlated. And if you look at the plot in the report, you will clearly see that this particular plot shows that the good air quality, bad air quality, and also the moderate air quality are actually separated if you compare them. If you compare the carbon dioxide and the nitrogen dioxide, if you compare them. So upon knowing this particular thing, this is when I now specify the models that I would like to use, which is the theory of statistical machine learning. So I listed all the models that I want to use. I consider decision tree, logistic regression, LDA, and also KNN. So I see that these particular models are actually feasible for this particular problem, which led me to using these three features: KNN, decision tree, and LDA. These are the three models that I use. Upon doing that, I optimize the data set by using cross validation. I cross validate it using different parameters. Take for example, for the KNN, I change parameter of K from K equals to 3 to K is equals to 15, so as to see the parameter that actually fit the data well, that perform well on the data set. And we can't talk about this without regularizing our model. The model actually performs somehow poor at some cases of the cross validation, but upon choosing the optimal one, actually the minimal error is just so low after I did that. So moving forward, I compare the models that I see that among all these features that I actually use, the decision tree perform better for the air quality data set. So I then move ahead and look at the feature importance that contribute to the performance of this decision tree, where I see that nitrogen and the carbon dioxide are actually the most important features in this data set. To make this particular model to be available to the entire world, then we can deploy it, which is a future thing I am actually looking forward to do. For the binary digit classification task, we are given k is equals to 1 and k is equals to 27. Using k is equals to 1 actually demonstrates somehow overfitting, because the neighbors that we are using is just one neighbor. This can lead to overfitting as we are taught in class. But when using k equals to 27, decisions are made between all the 27 neighbors in the model. So this is actually a good thing to consider, and it is able to generalize well on same data. So, and the ROC curve for the model comparison actually demarcate this. All the mistakes that the model made, I use the confusion metric to see them, and I'm able to see that though when k is equals to 1, it's able to even perform well on the unseen data, but it has actually learned the pattern of that particular data set. So that's why it's able to predict well for the 40% of the data test that we actually gave to it. Moving to the ultra high dimensionality. Ultra high dimensionality refers to we having, take for example, thousands of features, whereas the sample size that we have in the dataset is just 100. That is what we refer to as ultra dimensionality. This is where I explored 6 different datasets: the DNA, breast cancer, sperm classification, leukemia, prostate cancer, and the colon cancer. So upon looking at all these things, I'm able to see that ultra high dimensionality actually occur even by using the k value, which is k is equals to n over p. So that one helped me to see how big that ultra high dimensionality is for that particular data set. I'm able to detect all those things in this particular data set, which actually introduced me to another world of ultra high dimensionality. For quite a while, I've actually not come across some data set that will be this big, but with this particular section, I'm able to see that ultra high dimensionality actually occur. Thank you so much for this assignment. It's such a wonderful one. Bye.